Hi, my name's Abby. I'm a AI developer advocate and growth engineer at Comet, and I'm here with my colleague, Basic Cop, as I was recognized as our
I'm also a researcher and developer experience at Cont as well.
awesome. So, we're gonna do a demo for you tonight about the Google ADK and how to log and how to evaluate that using GoFed. But I just wanted to give some really quick background before we jump into the code. But actually, even before that, just to get the fun part out of the way first, because I always forget to do this. If I keep this at the end, so that's when I get it out of the way now. We are doing a Lego giveaway tonight. So if you scan the QR code here, fill the form, give our Rebo a star, you'll be entered to win. Tonight, they have a Wally and Ease Lego set, and we will be drawing that by the end of the night, April this night. I'll leave that up for a couple more seconds. And then I'll go through the slides. I'm going to keep really short, but I just want to provide a little bit of context for what this is about to show you. So if any of you come from a software engineering or DevOps background, you're probably really familiar with observability. But in AI, it's a lot more complex because LLMs are non-deterministic. Then you could about yeah, sure, sorry. So if you come from a software engineering or DevOps background, you're probably already familiar with observability, but in LLMs, it's maybe a lot more complex because LLMs are deterministic. So that means that traditional approaches like hard-coded logic or look at try except clause, it's not only not going to scale, but it's not going to work because you simply can't anticipate every possible output of an LLM or an agent. And it might seem very intuitive at first that LLMs are non-deterministic since the output is the sampling from a probability distribution. But it actually runs a whole lot deeper than that because even when you set aperture to 0, yields, which theoretically makes sampling deterministic, LLMs still will produce different results. So, there we go. Thinking Machines Labs recently published an article. It's not a little bit viral, so we'd be already seen it. Maybe you haven't, but I just wanted to highlight their recent research shows that non-determinism may actually be due to how kernels behave when batch sizes and inference loads fluctuate. It's not part of the discussion. I'm not going to spend a lot of time here. But the point is that the non-determinism in LLMs runs very deep. And the same inputs won't necessarily yield the same outputs every time. We need traditional evaluation metrics or methods that you would use in software engineering who simply don't work for LLMs and therefore agents. So some other reasons that pondering and evaluating LLMs is hard is that many AI tasks don't have a single correct answer. So if you think of, for example, open-ended tasks like summarization, content generation, reasoning, you may have multiple outputs that are equally valid. The same meaning can come from different versions of language, and you can say the same thing in many different ways. So simple n-gram metrics, regex, or pattern matching is not necessarily going to be helpful because it's not capturing semantic meaning. Even if you consider some widely used evaluation metrics that do capture a level of semantic meaning, things like relevance, coherence, conciseness, those are all subjective. So when we talk about a ground truth for relevance, what we're really talking about usually is a single human's point of view, their annotation, or an LLM, and human expert annotators often disagree, right? So that's a whole problem in and of itself, but human feedback remains crucial, but the word ground truth is very misleading. And the point being that capturing what good looks like is especially challenging when you have no single correct answer. Ground truth is subjective. And finally, AI systems also drift over time. So you have model updates, have prompt changes. You may even have subtle shifts in context handling. And these will all change your outputs, even if the application code that you've written and that you've run before, even if that hasn't changed, that can alter the output of your application. So this is a sort of funny example that went viral in 2023 when a chatbot for a Chevy dealership agreed to sell a user a car for $1. And the funny part about it is that this user actually took the dealership to court and won. And they were forced to give them a car for $1. My favorite part is apparently no TC's backseats. That's where you leave it. So remember that series. I know I will. But the last funny point is that these there are real consequences to these systems making decisions, and it's really important to evaluate your systems. And in order to evaluate your systems, you first have to be able to see what's happening in them, and collect the data that will allow you to start coding. I think it's the last slide. Monitoring agents is even harder than monitoring LLMs. Why? Agents just add to the complexity of LLMs, right? So they're multi-sec workflows. You have more moving parts, more failure modes. You're using external tools. You have silent failures. You have external dependencies. You're chaining LLM calls. So when we talked about non-determinism in a single LLM call, once you start chaining those LLM calls, you're just compounding potential error and variability, which makes it even more difficult to predict what's going to happen. There's dynamic memory context, so some kinds of continuing drift, on-skin drift, performance can degrade over time. And ultimately, when you're evaluating, you're not just evaluating your outputs in agents. You're evaluating the entire process along the way, right? So it's your agent has output the correct answer, but for example, it's called 35 tools when I really only needed 2. You have a serious problem because you are going to be using a lot of extra compute, and probably it'll come a lot of extra latency. Likewise, it's the reasoning your agent used to get to its output is, for example, racist or otherwise harmful or problematic. You have a serious problem. You can't deploy that application with pressure. So that's why monitoring and evaluating agents is very, very tricky. And now for the part I'm sure you're much more interested in, the actual code. Vincent is going to walk you through. We have a recipe agent example. Basically, the application will ask us for some ingredients that we have in our fridge. We input them and it's going to give us that recipe.
So the Google team were talking about like how you can write agents. So using Python, we can use a framework known as Google ADK or Agent Development Kit. This is provided by Google, so this allows you to write agents. I'm going to share this code with everyone afterwards. I'm not going to go through detail, but I just want to explain a couple of things here. So we're going to use OPIC, which is the platform that we're using. We're able to import that package and use the integration that comes with ADK, but also import the packages required for Google. Essentially, what we're going to do, we're going to define a number of agents. So we've got an agent here. It's using the Gemini. It's a recipe suggestor. It's going to take the ingredients that we're going to feed it. It's going to come up with recipe. We're also going to have a recipe researcher that's going to look for variations, give us context. And we're also going to have like a master agent that's essentially going to make sure that the sequencing of the agents, the steps they go through, one information passing through another sort of works. And then just some scaffolding for us to actually take that data in. So just a 200 lines, you could probably make it less, make it quite neat and small. But it's just to show you, like from a code perspective, there's not a lot of complexity. A lot of that complexity is handled for you by the frameworks like the ones provided by Google. So to kick us off, I'm going to run this code. And I would like some. Perfect. Can someone throw me some recipe ingredients that you would put in food?
Right.
So one at a time.
Tomato.
Tomato.
Garlic.
Tomato, tomato. Garlic. I'm not gonna put Nutella because there's a fun one. One more.
Onions.
Onion and I put hay. We'll see what happens with the ignore the error messages though. It's just so it's come up with, what does it come up with? A 15-minute cook time, 2 medium ripe tomatoes, onion, black pepper. It's got the gummy bears. Wow. So you cook it up, you serve it. This is absolutely disgusting. Haribo spine is reset. Actually, you know what? That actually might work. For relish, this is the first time I've done this where I actually looked at it. I'm thinking that might actually work. That might actually work. Wild enough that it might actually work. And then it passes to the next agent. So it starts to give us some context, give us some nutrition, give us some tips, some variations. You probably leave out the Haribos. And you kind of see how that works. So the agent framework obviously logs a lot of that data. And the platform we work with is called Comet, OPIC, which is part of Comet. And you can get started for free. You can sign up to an account. You can get a key. You can link it with your code. And everything you saw gets logged and pushed out. So that conversation we just had, if I go into my Google ADK project here, that conversation gets logged. So that one conversation that we just had, all these little steps that you see sort of get put together. I'm trying to find, sorry, we're making a lot of changes. So that's what it looks like. The actual agent execution is we have a recipe master agent, which talks to the rest, which passes that information to the recipe suggester, which comes up with the research. And that actually goes off to the internet, finds nutritional information and looks for recipes and things like that. So all that data gets collected. As you can see, there's like a lot of steps going on in there, right? So any one of these little steps in between, something could go wrong. It could take a lot of time, it could cost a lot of money, use up a lot of tokens. And this is where, imagine you start to do this at scale, becomes quite complicated. Now, the last thing I'm going to quickly show you, because I don't want to bore you all and take up a lot of time. I'm sure there's questions and there's demos after this. But we can use large language models like a Gemini model with an instruction to basically take all the inputs that we've given it that's been sent here to look at it from a different combination. So one of the ones I'm using here is look at it from a taste appeal. How nice do you think this is going to taste? Look at the ingredients, look at the seasoning, and look at that. So we can actually tell a judge or look at another AI model, an agent, separate it to look at the whole interaction and kind of give it a score out of 1 to 10. So if I go back to that specific run that I did, I was having problems over there, so I hope you can see it gave it a score of 3 out of 10. And if we look at the feedback score, it's going to say the concept of Haribo tomato presents a significant culinary challenge. I think that's see. So we're like, you can have a lot of these conversations happening in your agents or things happening in your agents. These scores allows us to quickly give it a score. It could be true, false. It could be 1 to 5, whatever your scale looks like. And it quickly allows us to just dissect those particular use cases that have gone wrong. Could be a customer's or your internal testing, and then allows you to then go through a refinement process. I was finished anyway, so yeah. Thank you.